While I know a lot has been said on this subject already, this is my own take on everything that's going on at the moment between Apple, the FBI, and all to do with PIN numbers, etc. So this is my Apple GovOS and PINs, or why the FBI getting access to a single iPhone is such a big issue for us all. This is the first video of two, and this is going to cover the theory section of everything that I am going to talk about, because in the second video I'm going to do a practical demo, ironically on a Windows machine, on how you can brute force attack a PIN number and get the information out. So this video is going to be quite simple and straightforward. You're not expected to know anything about the case particularly or anything technical, but having a technical understanding is probably beneficial because of what I'm going to cover. These are the areas that I'm going to cover, and then obviously, as I say at the end there, video 2 will be a practical demo. So firstly, and very briefly, let's go through what actually is encryption. If you imagine we've got ourselves a piece of code, a program, which is going to do one thing, it's going to encrypt information. This means you supply this encryption box with a special password or key, put whatever it is you want to turn into something that people can't easily understand as an input, and out pops a load of gibberish. This gibberish, though, is very, very special gibberish, because in this particular encryption box, if you put that through as the input and give it the key, you can decrypt the information back into hello. Some systems are a bit more secure than this, and they actually have two different passwords. One that you use to actually turn something into encrypted data, and another one which you use to decrypt the data. This is used on the internet for things like online banking or whenever you're doing any form of e-commerce, which means that the server that you're connecting your system to is the only thing that supposedly can get the information out. Not even you, as the person who owns or has put that information into the box in the first place, can actually turn it back into the original information. There is a third form of encryption, also known as hashing, which isn't technically a form of encryption, which is a one-way process. So when I turn the word hello into the gibberish, I actually can't turn it back into the original data. This is going to be important later on. In summary, there are three forms of encryption that we're going to talk about. So-called synchronous encryption, where you use the same code to encrypt and decrypt, asynchronous encryption, which uses two different codes, and one-way encryption, or a hash, where you cannot work out the original code from the output produced. Now, John McAfee, whose name is synonymous with antivirus software throughout the world, even though he doesn't actually run that company anymore, said something really interesting a few days ago on American live TV.
Joining me tonight to discuss this, John McAfee, cybersecurity legend and developer of McAfee antivirus software, and also presidential candidate for the Libertarian Party. Mr. McAfee, good to have you with us tonight. Appreciate your time. When you hear the Digital Security Commission, what comes to mind?
Well, more spying is what comes to mind to me. Let me try to make this issue simple for the American public and for the FBI, who clearly does not understand. These devices are computers, whether it's an Android phone, an iOS phone, or whatever. Inside is a processor, which is a computer, the instruction set, which is the iOS and all the applications that you run, and the memory in which you store your data. Now, let's take the FBI case. The FBI wants Apple to change their software so that it removes the check for security, so that we don't check for security anymore. Once it has that software, it can use that software on any phone. But they say they only need it for one phone. So I'm going to tell the world exactly how we do this. Now, I'll probably lose my admission to the world hackers community. However, I'm going to tell you. You need a hardware engineer and a software engineer. The hardware engineer takes the phone apart, and it copies the instruction set, which is the iOS and applications, and your memory. And then you run a piece of a program called a disassembler, which takes all the ones and zeros and gives you readable instructions. Then The coder sits down and he reads through. And what he's looking for is the first access to the keypad, because that's the first thing you're doing when you input your pad. It'll take half an hour. When you see that, then he reads the instructions for where in memory this secret code is stored. It is that trivial. A half an hour. Now, I said 3 weeks. Why? Because if I got the flu or a cold, I did not want to have to eat my shoe, like I said, on Neil Cavuto. But it is a half-hour job. The FBI knows this. Apple knows this. And this is not an indictment of Apple. Any computer, and this is a computer, any computer that falls into someone's hands, well, anybody can do it, which is why corporate data centers keep their computers locked up, and which is why we ought to keep our own phones locked up. It's not an indictment of Apple. Any computer, any software, whether it's Android, Apple, or what have you, can be done. We can do this with any machine. And it is a half-hour job. The FBI knows this. And if it does not, we are in deep trouble. Deep trouble. Because it should know this.
If you imagine you have an area of memory that is able to store the PIN number. So here we have some storage memory. And there we can see that the PIN number is actually stored in this memory in some way. I'm using RAM, but that's only because that's how he would do it if it was actually running on a virtual computer. This would actually be stored on flash memory. So the process we're looking at in the iOS startup that he's expecting for his program is that you type in the PIN number, and then the program compares that with the memory location. If it's a match to the PIN number, you unlock the phone, otherwise you don't unlock the phone. Simple as that. Now, to be fair to what was being said on the video, that's the very simplistic view, but it does actually involve encryption as well. So there's a couple of extra stages. Because the PIN is actually encrypted in storage memory, you can't actually read it directly out of storage memory. If you could do that, then the phone would easily be able to be unlocked by anybody. So what he's suggesting now is you take the PIN number off the keypad, you encrypt it. It's a one-way encryption process, a hash. Does this PIN match the memory location stored? If it is a match, unlock the phone, otherwise don't unlock. Now, depending on how this encryption is performed, if it's synchronous encryption, two-way encryption, there's a really easy, quick way that you could actually learn the code for the phone and unlock it. You just find the encryption code key, the password that's used, that would actually be stored in the programming language. You find out where in memory the PIN number is being held. You therefore decrypt this PIN from memory, see what it is, and then use it on the phone directly. If a public and private key encryption code is working, you can find the public encryption code from the program code, find out where in memory the PIN is held, put this information into a computer, and then you can try every single PIN combination from 0000 right the way through to 9999 until you make sure you get the right one. So all you're doing is taking the number, encrypting it, comparing it to the one that's held in memory. Eventually you get the right answer, so you know what you put in to get that code, and you use that to unlock the phone. Again, very simple. There are some problems though with this technique. Firstly, this is not actually how the iPhone works. Secondly, because it is such a big issue, it really isn't how the iPhone works. Because the big difference between what has been discussed here and in that video and what actually happens in a standard encryption system these days is that no PIN is actually held in memory. So let's go through how encryption actually does work on iOS and on Apple iDevices. This is all taken from the Apple public security systems that they've got, and there's huge PDFs you can download which explain in minute detail everything that happens. I'm going to just go through a small subsection of this really to try and explain exactly how it all works. There's a chip built into all modern phones, including the iPhone 5 that we're looking at decrypting in this particular case, or 5C, called the Secure Enclave chip. And this chip holds a unique identifying code. Now this unique identifying code is not built into the software, it hasn't been put into memory in any way, it is literally built into the silicon of the chip itself. It's etched in at the point where the phone is made, and every phone has a completely unique code. This is impossible to get hold of using the software, other than software within the secure enclave itself. So what happens when you type your PIN number into the phone? The computer, iOS, the operating system, gives that PIN number encrypted into the secure enclave, which then uses a form of one-way encryption, a hash, to create an encryption key. This encryption key is used in another encryption piece of code that allows your encrypted data to be decrypted. So this is what happens then in memory. That's still a very simplistic view over how iOS actually does it. As you can see in this diagram taken from their security PDF, the hardware and password key actually form other keys which are then used to encrypt every single file using a different piece of encryption, the details of which are stored in the file metadata, and that's protected by a file system key. So what about trying a brute force attack on the phone itself? Well, if you have a look, it would take more than 5.5 years to try every combination if you used 6 characters. Of course, 4 digits is a lot lower than that. But to try and improve the security, there's a delay between password attempts. Every time after you've tried the first 4, the 5th time you try it lasts a minute before you can try again, the 6th time 5 minutes, numbers 7 and 8 15 minutes, then after that, every time you try and put another code in, you have to wait another hour before you can type a code again. Now, these delays are enforced by the secure enclave. They're part of the system software. They're not part of iOS. They're part of what's actually on the chips themselves. So if you really did want to try and do a brute force attack using a computer in a similar way to what John McAfee has said, this is the stages you'd actually have to go through. First, you have to break open the secure enclave chip on the phone that you're wanting to use it on. You have to use some either acid or abrasive cutter to take the top off the chip so that the silicon isn't damaged. The reason you don't want to damage the silicon is twofold. You need to be able to see the code, so if you damage it you won't be able to see the code under an electron microscope, but also if you damage this chip, the phone won't actually work anymore and you've lost all that data anyway. You then have to get the encrypted version of the file system key from the flash memory of the secure enclave, get a second part of a key from Apple by asking nicely, but having this sort of key means that you could actually create your own updates to the operating system, so they don't actually give this out. Take a copy of all the encrypted memory from the device, and then try and brute force attack the pin, but each cycle would actually take a good couple of seconds to do, and because of that it would actually delay the process going. So all these different steps could lead to you destroying the phone that you're actually wanting to get the information off from, and it could probably take a long time to actually do each of the different steps. All in all, getting the information off the phone probably won't reveal anything vital in the time it would take to actually do this. So, as we say, you can actually brute force attack directly on the device as long as they haven't switched on 10 hits and it automatically deletes everything, but this delay mechanism kicks in. And this is where what the FBI wants comes into play. They want a new update made of iOS that allows you to brute force attack the phone without any form of delay. Not only does this require huge changes to how iOS works, the new operating system would have to actively fight against the secure enclave to stop it putting in the delays. It's not just as easy as saying, right, this bit of code says after one attempt try and delay for X amount of time, because that code isn't in iOS, it's actually built into the hardware. And it's generally a very bad idea, because it sets the precedent. Would you really want your data being accessible by people in Russia or China in the same way? There are technical worries, as you can see there. And it's not just for the one phone. Any iOS device could be updated in this way. You might not have anything to hide, but there are always going to be secrets on your phone that shouldn't be revealed, whether it be Apple Pay with your credit card details, or maybe some secrets about a company that could be exploited by competitors. There is something else that has to be brought to the forefront, because it's been used within this investigation, and that's the backup issue. Now, as you can read on the screen, the encryption key is in hardware, so if you were to create a backup using this form of encryption, you wouldn't actually be able to use that backup except on the device that you created it from in the original place. So if you were using a backup to, say, create a new phone because you've upgraded your phone, you want all your data available on it, it wouldn't work. Also, it might not work when you are trying to move to another phone because it's been stolen. So they use a different form of encryption for any backups that are put onto iCloud. And as long as you know the iCloud password, this information can be decrypted. It's this information that's already been given to the FBI by Apple. If the phone was set up to automatically back up when plugged in and on Wi-Fi, they could have instantly got a new backup on the device because one hadn't been taken for several weeks, and then the access to the phone data would be done through that backup. Simple and straightforward. But the iCloud password was actually changed, and because the phone doesn't know the new password and no one can type it in because they can't open the phone, they cannot let it back up. It won't work. So in summary, what I'm going through here is the theory behind how this encryption problem and huge news story has come about, and how it's not quite as simplistic as some people in the media think it is. However, there are entry points and there are other things that we can look at. In the next video, I'm going to show you how to actually do a brute force attack using a pin on a Windows PC that's emulating an iPhone.